All right, how you guys doing out there today? This is Miss Muscarella coming at you, and I'm going to give you a quick rundown, a brief review of the graphing project in Desmos. So in the graphing project, part one, remember, you had to watch the video, take a look at that, and make sure when we do our little equation, because if you put your data in, we might have to add this piece right here, the 0 to b to n, after the letter D when we go to type in our general equation for that. But remember, n is not going to be just n. It's going to be some number, probably less than 10. But whatever number we put in there for that is going to allow us to create a picture that looks more like the one on the left than the one on the right. Because we want to be able to create a nice sinusoidal curve or a wave that looks like the one on the left, not the one on the right. So again, remember, when you do that, be sure to name your project correctly. Now this particular example, in example one, you would name it, so if it was mine, I would say Musky Sinusoidal Regression Example 1. All right, most people are okay with that, but it's the exact example 2 that people are having a little bit of trouble with. So we'll go over, again, how to share the link to your graph. So when you do come up with your graph, you go over here next to your name, and now there's a little Global Math Art Contest trophy there. So you can click on share, then copy, and then that would be what you would post underneath anything that says, share your link below. So make sure you share that link instead of the link that is at the top in your web browser. Don't share the web browser link. Share your graph link that Desmos provides for you. All right, so let's take a look at part 2 here. Now in part 2, notice we've got a couple of cities here. We've got Syracuse, Washington, and Austin, Texas. And in all of these, it's going to be the same idea as what was presented in example 1. We've got 3 cities, and we've got 12 months of the year. And this is the temperature data for those 3 cities. Now our directions say, have all 3 graphs shown at the same time, create a folder and label the city with each folder with the city's name. So each folder is going to have the table of values and the sinusoidal equation. So those are going to be the things in there. And then when we name this one, we're going to say, Musky Sinusoidal Regression Practice. So that would be the name that I would give to this particular one. So let's go ahead and do this. So you would start a new blank graph, and then like where I have Syracuse data, I would type in the name of it, and then you would just save. So you would just save that graph. Bink. And then you've got the name of it correctly. So to add a folder, remember you do plus and then folder, and then that'll add a folder. And we'll name each folder, we'll do one for Syracuse, DC, and one for Austin. Now the challenge with this, all right, so the information that we're provided, this temperature data, we're going to have the months 1 through 12, the numbers 1 through 12, to represent January through December. And then the temperature data is what are going to serve as our Y values. So 1 to 12, they're going to be the X values, and then the temperature data are going to serve as the Y values. Now we're going to enter those pieces into a table. And remember, to add a table, you just do plus and then table. So I'm going to go up here to Syracuse, and you can see I already have that information entered in for Syracuse. So 1, 2, 3, 4, 5, all the way to 12, those are the months, those are your X values. And then the temperature data for Syracuse is what's in Y1. Having said that and gotten all that out of the way, double check to make sure that your data is entered correctly, because that's where most people will make a mistake, is they'll just incorrectly, not by any mistake of their own, type in the wrong data by mistake. So double check that, make sure you're good. Once you have your data in there, next we've got to come up with the equation of that sinusoidal curve, and Desmos will help us with that. So go to the top right next to the name of the city. Hit enter. Now notice if I fold up Syracuse, so the triangle, how it's pointed down, if I fold that up, everything collapses. All right, so that's what we want. So everything that is there for Syracuse. The equation is going to be Y, and then just type 1. And then the tilde, and the tilde again, that's up by the number 1 on your keyboard. Usually you have to hit shift to get to the tilde. And then we'll type in the general sine equation. So A sine parentheses B and then X sub 1. And if we type in the number 1, that's automatically going to go as a subscript right next to the variable X. So BX minus C, close parentheses, and then plus D. Now that gives us a picture of our graph. But then we've got to make sure, because sometimes it got a little funky, so I might need to add this piece where I've got the brace. So the brace is right up next to shift, or it's right up next to the letter P on your keyboard. So shift and then the bracket button, which is right next to P, and then 0 is less than, B is less than some value. And that value will be less than your age. Now, if I put in the number 5 for B, and then close off the brace at the end. So now what I want to do is take a look at my picture and see how many does that go through or crisscross or touch. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's pretty good. That's really good. So I would be happy with a 5, 0 to 5 being the range of my B values for there. And that was pretty good. But if I were to put in a number, say like 15, or say 25, let's see, maybe 35, there's going to be one that's going to change it out here eventually. Actually, let's go with 51, nope. Let's see, 6, nope. There's one. So when we take a look at a value like this, I mean, this isn't good. We don't want this, even though that actually does go through every point. Yeah, but no, I want it to look more like this, sinusoidal curve. So cool, so we've got that. So that would be the equation for the Syracuse data. Now I'd repeat that process when I go through to do Washington, D.C. So let me turn off Syracuse. What we have to do for Washington, D.C., again, we'll enter our data and put that in. But here's what's going to be a little bit slightly different. So be careful when you do this. When you go to type in your equation, it's not going to be y sub 1, it's going to be y sub 2 because DC is our second y value. And if you notice right here in our table, in the table, the subscripts for x and y are both 2. So x sub 2, y sub 2. So that's why we want to type in, so x or y sub 2, and then the tilde, and then parentheses, a sine, parentheses, bx, and then again with the sub 2, so we'd have to make sure we put that in. And then you could finish off the rest. When you go to do the equation for Austin, Texas, when you go to type that in, it'll be the same idea, but this time instead of y sub 2 and x sub 2, you would have y sub 3 and x sub 3. So you'll go ahead and put all that information in there. Now, your scale, so hit the wrench button, and your x-axis, make sure that goes from, say, maybe -1 to 13, and your step value is going to be 1. Step value is going to be 1. For the y-axis, what you want to do is look at, you're going to start with -10, but then you're going to go 10 to you're going to round to the next highest 10. So if I look at the data for all 3 cities, Syracuse, Washington, and Austin, my highest temperature out of all 3 of those, it looks to be 97 degrees in Austin, Texas. So that's going to tell me I'm going to round that up to 100, right? So the y-axis is going to go from -10 to 100, but I'm going to go by 10. So my step size for the y's are going to be 10. All right, so I would go ahead and do that. So that's how to get the data input there and all of that. So that's for part 2. Once I have all of that done, I save it, and then I create another blank graph. Okay, but before we create we'll share it, copy that link, go back to your part 2, and then right below that, in this space, you would paste the link for the data that you have. All right, and that's how you enter that. Now on to part 3. So for part 3, you're going to go to some magical city that you want to go to, and you're going to make a prediction for the average highs, lows, days of precipitation. And precipitation is both snow and rain. So how many days do you think for the whole year there are for precipitation? So something between 1 and 365. And what's the average precipitation per month in inches? Hours of sunshine, the average lows. So those are going to be the predictions you'll make after you explain why you want to go visit that place. So decide on your place, then go here to the U.S. Climate Data website, and that is going to be the place that we're going to go take a look at. Now, Muskie loves Boulder, Colorado, so I'm going to take a look at, that's why I'd want to go there, because it's a triathlon mecca of the world. It's got all sorts of great stuff. So I'd make my predictions and then come in here and take a look at the data. Now I've got January, February, March, April, May, June. So when I go to set this up, I'm still going to have a table that's going to resemble what we just did for Syracuse, Washington, and Austin. Only one of them is going to be maybe degrees. You know, if I want to go to by the average high temperature, so then my folder I would just call it average high. In my other folder I would call that average low or average precipitation, whatever the two things are I want to investigate. So here for this one, now they separate, because it's Boulder, Colorado, they separate precipitation and snowfall. So you can add those together, that's fine, or keep them separate, you know, whichever one you'd like to do. But most people are going to stick with temperature on these. So you'd enter your temperature data, come up with your equations, and then do the same thing that you did for the Syracuse, Washington, Austin piece. And again, once you are done, then you'll this one's going to have a little bit different name. So this one's going to be named your first name, and then Sinusoidal Regression Project. After you've named it, share it, copy the link, go back to your project, paste the link, boom, and then using correct grammar, answer the several questions that are here, and then when you are done, click submit, and peace out, you done. All right, so that's a little bit review on how to do the Desmos Project 2. Hope that helps. Please be sure to reach out if you have any questions with any of this stuff. Oh, but real quick, I forgot to mention this part. So when you are, in your picture, so say like for Syracuse, you know, so there's my little data for Syracuse, and I'm all happy about it. But say I want to visit Syracuse when the temperature is between, say, 50 and 60 degrees. So I would type in y equals 50. And then so I'm going to zoom in on this right here. And you can see where, in this case, it's a green line. You can see where these intersect. So 3.53 and then 50. So that is when the temperature is going to start to be 50 degrees in Syracuse. And 3.53, so I have to think about which month is the third month. And that, of course, is January, February, March. So about halfway through March, according to the data, the temperature should be about 50 degrees. Now, if I wanted to be between 50 and, say, 60, I would do another line, y equals 60. And I would see another line up there. Wow, that's kind of funny. They gave the same color. So I'm going to change the color. So a little quick one on that. So boom, here we go. So up here at 60, so these are the values where I would have, you know, my temperature would be between 50 and 60. So 3.53 is the lowest 50, and 4.3. So somewhere between the middle of March and 4.3, so that'd be April, the temperature is between 50 and 60 degrees. Now, likewise, if I follow my curve around to the other side, I'm going to have another area where my graph is between 50 and 60 degrees, and of course the graph is Syracuse. So up here, it's at 10. Ooh, that's right at October. So that's October, and then down here where they crisscross, the green line and the curve. So the green line again is y equals 50, where they intersect, 10.7. So the 10th month is October. 10.7, that's almost November. So anytime during the month of October, pretty much my temperature will be between 50 and 60 degrees. After November, it's colder than that. Before November, it's warmer than that. So that's one other thing you may have to do in one of your projects if it says to add a, let's see, what do we do? Add a line to your project for the time of the year that you're going to be investigating. That's this piece right here. So create an equation for the line that corresponds to the time of year you'll be visiting. So you're going to want to do that to kind of take a look at and analyze your data. All right, mathletes, I appreciate your time and hope you have a great day, and I will catch up with you later. Peace out.